I forgot to set up music. I'm gonna do that. One sec. I know what I'm doing. Hang on, wait. Ah. Okay, wait. Why won't you let me? Da, 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 da. I guess it won't let me filter to just one small portion of my library anymore. So we're gonna go with the regular stuff. So, I don't have chat up because I'm not smart. Fix that. Chat. We have chat now. So I've got the finished, finished functioning prototype assembly working more or less. This probably needs a rebuild. That looks all kinds of wrong. But critically, let's pull this up. It's functioning. So I've had the thing printed over at my dad's, and it works. So, I mean, the concept is right. The big issue, and you can't hear it very well because I have it turned down at the moment, is that there is a little bit too much play in the detent, in the sprung detent mechanism. So I just need a little bit less there. I think my mistake was I took material off the bottom as well for clearance, so that the whole thing would have clearance in the tunnel, but I don't actually need that. I just need clearance on mostly the sides, I think. I wonder if there's a way to... there's not an easy way to like, slow it down so you can see what's going on, but the gist is that... well, I think I actually... No, that's right, I've already tweaked this part a little bit, but there's too much clearance in here. This is less than was modeled for that particular version, but I'm going to tweak it and make it so it fits better. So the idea is basically that these surfaces have to be always radial. They have to be always radial. So you can't ever have slopes or parts of them where they aren't like cross sections where they're not perpendicular to this axis, because then it doesn't have the whole face bearing on it. It just has, I think it would be the innermost part. I haven't checked to see where the interferences actually happen when you move them together, and probably the best way to do that would be to go to my dad's house, put some like marker on it, and just see where it comes off in the other part. But on the old version where these were straight, where this was a straight extrusion, they definitely would have been only bearing on the inner part. So let's fix that. Well, actually, hang on. Maybe they would have been only bearing on the outer part. I don't know. I have a crazy idea, so we're gonna try it. The first thing to realize is that for this first component, I'm doing a boundary extrude instead, using a 3D sketch, which is one of my favorite tools and one that I think is really underutilized in general. So you can draw a 3D sketch to define exactly where you want on your edges, and then when you go out of that 3D sketch and into a boundary boss feature, you can control everything. So you don't have to calculate draft, or you don't have to pre-calculate draft somewhere and enter it into the feature. You can do that all in your 3D sketch. So in my case, I've got well, the big one that I'm working on right now is that this guy is driven by this angle, which is driven by, oh, I forgot those are going to be the same height, but they aren't necessarily the same height. So I had to do this sort of weird, rather than making this line and this line equal, because otherwise I don't know that they're going to be the same height, because I don't know that these two lines are going to be the same distance from the origin. In this particular version of the model, I know that they are, but I can't rely on that, because in the future I might break it. So, looking at this, what was it that I wanted to do this morning? Oh, yeah, okay. So, I don't like that it comes down to a point, because that makes it sort of difficult to it doesn't form its own body correctly, and these faces up at the top here aren't like here. We'll just enter a 3D sketch, or exit the 3D sketch rather, and look at a cross section. If we look at a cross section perpendicular to the axis, these lines up here are not perpendicular, so the bearing faces won't be rubbing evenly. So what I'm going to do is, well, let's go into the 3D sketch, get rid of these lines. Whoops, come on, go away. How am I going to do this? Okay. I kind of have to figure out what I'm doing as I go. But basically we're going to construct a little sort of interim section here that lets me... Oop, hang on. Almost weren't in the right plane for that one. That lets me sort of connect all of this cleanly. So this guy's going to be along X. This guy's got to be along Y. Whoops. That broke something. Oh, this guy's not along X. Why the hell? Why are you all suddenly breaking? Like, there's no reason... Okay, I'm gonna clear all these. I think there was some sort of weird relationship going on there with one of them. Oh, that guy's not straight. And then... Oh, hang on. These guys can't be due up. They have to come together because I'm smart. That'll make sense when I actually finish drawing this. So let's connect these two. Merge. Merge. And there we go. Okay. Now we can do these ones along Y. Oh, those are already collinear. Wonder why it doesn't want to, Oh, not having those edges in the middle anymore sort of shuffle it all around. Now, what does it want? Okay, it just wants me to define how far apart these guys are. That's not too hard. I'll add a line here, and a line here. Make this guy along X. And then say this is... Actually, let's do from this point to this point, so that we know that it's guaranteed to be less than our hole diameter. But it's still picky. Why is it still finicky? Whoa, that's weird. Don't do that. Long Z. Long X. Uh-oh. It's gonna crash. It stopped responding. Yeah, it's gonna crash. Or rather, it may as well have crashed. Whoa. Nope. May as well have not crashed, because now it's just making fun of me. Oh, don't close. Cancel. This song, what is it? This Is Not the End by True Cuckoo. It sounds a lot like, Breath of the Wild battle music. Okay. So, these guys... This one's thrown a fit. These two guys should be equal lengths. Ah, there we go. Okay. Now, if I assign... There we go. Okay. Now, I can exit sketch. I don't need to have an upper and a lower triangle. I can just have... whoops, clear selections, and then I just get to pick my chains, come across here, and you can see what Boundary Boss does. It gives me very, very clean control over all my edges. So I'll come out of this. And now if we go over here and show me a right plane, these are all straight lines everywhere. So we can sort of sweep back and forth through this, which means that they're all always radial, which is great. Get rid of that. Detent, whatever. Now we add the base perimeter surface. We extend it to give ourselves a trim plane. And I don't have an intersect anymore because I forgot part of it. Intersect. Get rid of these two. Merge result. Consume surfaces. Boink. Attached. Whoa, what? Why did it do that? What? Just not want to play nice? I don't understand. Oh, goodness. Oh, there's two bodies here. Does it want a separate extra combine or something? And these two... Weird. Didn't want to merge them. Well, I don't know, you work around it. I should give this a serious name. Detent Boundary Boss. Detent Top Trim. Detent Combine. I did some reading on this today. It turns out detent actually means the having a brain fart. The detent is the pit that normally a ball bearing goes into. So this is the opposite of whatever a detent is. This is the bit that sticks out. Whoops. Okay, that looks way too sharp. So let's trim that back a little. Like before. Whoops. Why is that broken now? Oh, you know what? I don't think I even need these lines. I just realized that I might have the dumb. Okay, so if we drag stuff around now, it's all wrong, which is fine. We can make those equal. If we drag things around more, find what else isn't equal. Oh, and those aren't necessarily vertical, but oh, nuts. Yeah, those aren't necessarily vertical with each other. Whoops. I can't really make them vertical with each other. Whoops, what is going on there? This worked really well in my head, and it clearly does not work anywhere near as well. I think maybe I should just wipe it and start this over. I just have to think about how... It did make a lot more sense when everything went to the same point, but that wasn't really a guarantee. Like, that wasn't something that was necessarily guaranteed by the geometry. I mean, sort of is. You know what? What if I do accept that assumption? Oops. Pretty sure this guy is tangent to this guy. So anything up here at that height is going to be the same distance from the origin as there. So I'm just going to assume that. And I'm going to make my own life easier, and I'm going to stop trying to do this in a really dumb way. And I'm also going to wipe all of this because it's dumb. So let's do this from scratch. Okay, collinear. Actually, let's do this in an even more abundantly obvious way. Let's do this with construction lines and midpoints. Midpoint, linear, and linear. I want these guys to be equal. I want these guys to be equal. And that'll force everything to be symmetric. I want these guys to be tangent. Yeah, okay. Nice and safe. I want this to be, say, 5 millimeters, but I have to drag it all the way over there so it's not dimensioning from a face or something. Say, well, 3 millimeters. Let's make it really small. And I think I just need to define this width now. So let's say that's maybe 10. And the distance of this point from this guy is going to be, say, 4. Equal, if I make this guy perpendicular here. Whoops. Doubly perpendicular, please. This guy wants to be long y. These two equal, perpendicular. Cool, okay. Exit sketch, rebuild anyway. Come back here to the boundary boss and rebuild it from scratch. Cannot create a solid. What? Drag sketch. Okay. I guess it wants a little bit more. Yeah, this guy's fully constrained. Oh, why is it? Oh. Okay, so that should give me a pretty safe, like, window to work with here now. Shrink this guy around and move it around. Those suddenly become... Okay. Why did those suddenly become non-constrained? Well, they're constrained. They're just throwing a fit. Okay. Good to know. Exit sketch, rebuild. So now we're going to do this again. Okay. Clear selections, clear selections. It's gray on gray. I know it's really hard to read. I can barely see it too. And SOLIDWORKS has decided it's going to do some very silly things with my my edges here. Hard edges, please. The other thing to remember is if you don't pick all hard edges, it's going to give you weird swoopy ones. Like if I disabled any of those, they would look very strange. So now we have two solid bodies. Let's try ticking on merge result. Actually, let's not. Let's not ever do that. Base perimeter surface. Give me a top surface up there. Extend it. Trim. Except it's not trimming right for some reason. Why is it not intersecting? Selections. Intersect. Get rid of these two. Say OK. Merge result consume surfaces. Didn't actually merge it, which is annoying. And the 3D sketch is still visible. Now it's not. But that's looking pretty good. There's a hole in the right location. Looking right. Tunnel nominal offset, which is the point, or the 3 millimeters. Now I need another move face to offset those a little more inward to the tune of... Actually, no. I specifically promised myself I wasn't going to do it on this part. I was going to do it on the other part. So we'll save this for now and go start working on the other part with the detent. So let's see. What's if I say? I'll just pick that edge. It is 2.5 millimeters inboard, which means that is a little bit sharp. This guy could use some fillets too. Oh, not 10 millimeters. Please, just 0.4. Let's look at it in context. Still some intersections here. Well, I think I'm also not looking at this in the right plane. Evaluate, interference detection, calculate. Oh, there's a little bit of interference there. Whoops. That's where the base, where the bracket itself meets the amps mount. That's not good. How'd I do that? Is this too large? 9.8, 9.6, wouldn't you know it? I thought I fixed that. Guess I didn't. Okay, let's go... Actually, let's tweak the spacing in there. So let's turn off the cross-section for a bit and go take a look at this part. So in here, we have the tunnel slider clearance, which on the last print was 0.6 on the one that my dad showed. This one is going to be 0.4 and only around the edges. And we can inspect that if we come back to the main model and say, give us a right plane. We just slide it along until we're at the interface between the slider. There we go. That's what we want. So butting up against the bottom, so we have at least one solid face, and then plenty of clearance around it so the thing can still slide through. And critically, leaving as much material as we can on this guy while doing most of the removal from up here. So do a quick save all. Yeah, okay, that looks good. Now we're gonna figure out this guy. So this part's gonna be more complicated because my 3D boundary boss silliness has to be relative to this plane. And over in this guy, I just realized that it would make a lot more sense if rather than this being tangent, it was defined as some distance from the origin so that it would be very easy for me to replicate with construction lines. So we're going to say that this is now, oh, I don't know, 10 millimeters. So that way it'll make sense. I'll draw an intermediary triangle that lets me control the features of all the other ones. Just gotta look at this and remember it. So 10 millimeters from the center. I'm 10 millimeters wide, 4 millimeters high. I mean, I'm always gonna be 4 millimeters high, but it's good to have the reference. So 3D sketch. Ooh, hang on. This pre-detent chamfer. I'm gonna suppress it for a bit because otherwise it's gonna make my life really hard. So start with a rectangle. Oops, what's it doing over there? Ooh, hang on, I could just draw a plane on this guy first. Coincident. Don't like where that is though. Can I specify it a different way? I want it coincident with that guy. I want it perpendicular with this guy. It's not really enough to give me the angle I want. Let's see. We should have a hinge axis. Oh yeah, but that's just specified with an angle. Okay, I'll just draw a plane on the backside here. Just accept that it's going to be a kind of a funny angle. And then what I'll do is I will define my other lines to be perpendicular to it when I need them to be. Bunch of collineating. Collinear and collinear. Parallel and collinear. Make these equal. Select midpoint. Where'd my feature tree go? Okay. I want hinge axis, and I want the midpoint of this guy. I said I want hinge axis. Okay, display hinge axis, please. Or don't, I guess? Oh, I probably have hinge axis visibility turned off. There we go. Okay, this guy, and the midpoint, and this guy. Please give me both at once. Coincident. Thank you. Kind of an ordeal. Perpendicular. And so now, no matter what I do, this guy is always going to be at the right angle for my detents. Now we draw an extra construction line, which we're going to use right now to define from that point up to here. Let's say that is 10 millimeters. We're also going to come over here to the same angle. Okay, so 10 millimeters. We want to be... Oh, why is it putting it up there? Why is it doing that? It's like, hey, I don't want you to have dimensions where you might want them, so I'm going to be lazy and just dimension point to point. What the hell? What? this guy, it's only going to be 5. Why won't you let me dimension that? Okay, let's get off the plane for a bit. See if I can't dimension it that way. There we go. Okay, 10. Gotta draw some extra lines. Make sure that everything is aligned right. I'll make him on the plane too. Now, I think I just need to kind of guess, make these guys equal, give this some sort of set distance. Oh, I could probably make these arcs if I wanted to. Yeah, let's do that. Let's be weird. These are going to be arcs now. So let's get back in the plane. Make these two guys go radial. Make them select the arc, then the point, then you can say concentric, and now things are sane. Whoops, these are not parallel anymore. Why are those not parallel? Call that 15, which will definitely give me clearance, so that I'll always have, it'll go past the fillet. It might make getting in there a little bit interesting, but we will fight the troll that's guarding that bridge when we come to it. Also hide this plane because it doesn't need to be there anymore. I'm not actually sure I can do that, because then these ones have to be arcs, which wouldn't work. Yeah, I don't think I can do that. Whoops. Makes my geometry more painful. Not painful geometry, he said sarcastically. Oops, that's too much now. Oh, I see. Hang on. These guys aren't parallel. Nor are they parallel to other things to which they should definitely be parallel. So now we can get off the plane and switch into the land of very strange into the land of trying to make this make sense. Perpendicular. Perpendicular. So now that guy's defined, which is great. You can bring him over here. Say you are now perpendicular to these two. Oops. Perpendicular lines. Oops. I want those all to be construction, please. Why is that not defined? Oh, because it doesn't have a defined height. Smart. Okay, this line to this point was 4 millimeters. Wow, that looks a lot bigger than the other one. Well, nothing to do but forge ahead. suddenly got very blue. Time to go see a therapist. Add more perpendiculars. Okay, so 10 millimeters out, 10 millimeters across, 4 millimeters deep. Oh, phone charge alarm. Okay, let's try boundary cut. Probably gonna break horribly. I like how it just defaults to spinning your part around wildly. Like, it assumes that that's what you want. Yeah, if you don't select these other edges, it's gonna give you weird curvy ones, so be wary of that. But if you give it defined edges, it doesn't have anything to do except exactly what you tell it. Which is exactly what I want. Except that. Don't like that. I'm gonna delete that. Oh god, it's not gonna delete. No! Oh. Booey. Okay. Yeah, let's do... I have to do this a really gross way, I think. I don't think there's really any other way except just giving myself a little bit of extension downwards. I mean, I could try and extend the pattern, but I'm not sure it's going to cleanly clear that fillet, so... Away we go to the strange and horrible creations land, where Clark draws things. Okay, let's grab all these edges first. Make sure they're all equal. Alt Q, all equal. Let's make it 2 millimeters deep is probably fine. And all of these interim lines in here now get to be construction. I have to add a little bit more down here so we can still get all our cross sections. I'll add the 3D sketch, boundary cut throws a fit. All of our groups are now broken. We have some extra ones we need to make. That surface is just all kinds of jacked up. Whoops. Yes. Yeah, if I delete that, it's just going to break horribly. So I'm going to pretend it's not there. So then the first detent cut comes in. We can see that it's on the right axis. The second detent no longer exists, which is kind of annoying. So we're going to tell it, don't replicate that one, replicate this one at a funny angle. Hey, that's not bad. I expected that to be much more gross than it was. And you know what? I'm going to extend the depth of this further so that we can get a clean face into there. And I can also delete that first detent cut too. And now there's some equations breaking. Why do I have equations breaking? Ah. So some random stuff from defining the detent, I suppose. Okay, let's increase this to maybe... Oh! I had it sized to be equivalent to the fillet. That's what I did. If I delete this face, and this face, what does that get me? Breaks. Okay, what if I delete just those faces? No? Oh, phooey. It's not as easy a solution anymore. What if I do things in sort of a clean order? Can't do them both at the same time. We're just going to go for maximum gross here, I think. Let's see, where do these fillets come from? Oh, they're part of the amps fillets. Okay, well, there's not going to be one on this side anymore, because it's getting in the way. It's very rude of it to do that. Oh, what? Those... Why did those break? Oh, do I have to delete that guy too? Oh my goodness. Hang on. What if I just have really... What if I'm just tremendously stupid? What if I delete all three of these? Nope. Okay, that does break it. So I do have to get rid of the fillet on this side. That's fine, I think. Get rid of all those. Yeah. Yeah! Yeah. That might be too steep, but that's fixable. Second detent cleanup, but for real this time. Well, this one's gonna break because it doesn't have any of its faces there anymore, so... This is now the one true second detent cleanup. And we added 3mm fillets in here. And then we had a second fillet that was operating on... What's up with that face? I guess that fillet's just going to be weird, and that's the way it is. Oh, that wants to be more like before. Hey, cool, connected to start loop. Nice. Nice. detent fillet B. I am going to add... oh, I don't know what was there before. Probably 1mm? Oh. Yeah, I have to do it after this fillet because that gives me these surfaces to chamfer. That looks kind of wrong. That looks more right. The offset face rather than the distance chamfer can sometimes play nicer. Or sometimes it'll just throw it in your face and not work, like what this one's doing. Why is that one just throwing a fit? Well, I guess that one didn't get a chamfer then. No, I need to give it something. Anything's better than nothing. 0.8 is better than nothing. And you know what? It looks kind of like what it did before, so calling that a win. Okay, so that's all of those. Oh, hang on. Oh no, that exterior chamfer's that one. Okay, we're all good. So let's hide the hinge axis. Save this. Realize that my music has ended. Restart it. And go take a peek. So we should have some broken mates now, which is to be expected. We've got perpendicularities that are no longer there. That is not a cylindrical face, which is annoying. But it does look like it mates up pretty nicely, so that's good. I don't think... Oh, you know what? I have that plane that I can use. In the hinge component, I have, in the detent features, I've got that detent sketch plane. So we can get rid of that missing face and say, to this sketch plane, I would like it to be parallel. Easy peasy. And then we come to this other perpendicular feature, which is kind of a face that no longer exists, and tell it to go perpendicular to that detent sketch plane. Rebuild, save, and up, and down. Cool. Let's take a quick peek in this plane. Verify that all of our cross sections check out. Yep. Very cleanly. Very, very cleanly. I am a little worried that this detent's going to be a little stiffer than the last one, just because it's sharper on the interior, which means the angular ramp is going to be stiffer. But that's, I think I can just, instead of having like a 4mm height, maybe a 3mm height, and that should tune it down quite a bit. So let's go do that right now, actually, before I forget. First detent cut. And then over here, say 3 mils. That's still pretty steep. 2.5? Eh, 3. Nothing to do but print it and try, I suppose. Do a quick check in here. We had 0.6 last time, we'll try 0.4 this time. Other thing I can do... Well, I don't want to make this hole too tight. Right now it's 6.6. Let's change that to a close fit instead of a normal fit. See what that does to the 6.4. Yeah, we can shave 0.2mm off. That's fine. That is a perfectly acceptable amount of tighter fitting around the fastener. So the only parts I changed were this guy and this guy. Nope, that's a lie. I changed this one as well, didn't I? Yep, because I put my clearances on that side. Change it to 0.4 instead of 0.6 like it was before. Okay, so I gotta reprint all this. It's only gonna take like 4 or 5 hours. It's fine. I don't think anyone's gonna be putting the thing together again tonight, so. Morning project for my dad. Oh, one other thing. if we look at the fitment, can I zoom in? I don't think I can zoom in. Anyway, you can see that the hex head is sticking out on the left side. The bike is facing towards the bottom of the screen. The back is way out there. And you can see that there is a fastener that's not poking its head, or that's not seating its head correctly. So I'm going to bump this out just a little bit, since I'm already going to be reprinting the thing, so 10.2. Head restraint. Let's see, backside corner. Tab cavity cap. So left tab cavity. Then we've got the transition section and the center extrude. And let's see. Center lofts, center lofts and extrude. We've got the M6 through hole. Oh, actually, this is all at once because I mirrored it. I forgot. Center section cutout. Got the slider tunnel. These two guys could actually go at the end. Slider clearance should come up here. Slider tunnel fillets can come up here. Tab pocket can go down there. Logo cut can go at the very end. Well, we'll leave the logo cuts out in the open. But this stuff, this is all tunnel slider features. Oh, slider tunnel, because it's the tunnel for the slider, not the slider for the tunnel, which is a pointless distinction and the hill that I'm going to die on today. Let's see. Cavity finishing features. Cool. Got that feature tree all cleaned up. This one's short enough that I think it's fine to leave as is. But, I can't. Detents. If I go to the slider base, I go after that to the detents. Yeah, okay, that's good. Detent fillets. Good stuff. That's probably all it needs. I think I could probably just print it now. I am a little worried about the text here. It being, it's going to be in the bottom face, which means these have to adhere really well in order for it to not look like crap. But chances are it won't adhere very well and it's going to look like crap. But I'm not going to remove it, so sue me. Okay. Let's do a quick evaluate interference detection, calculate. Ooh. It does not like my silly faces. Oh, and those are interfering now. That's dumb. Okay, just the tiniest interference. And possible interference that it can't tell because they're so tightly up against each other. Awesome. It's exactly what I'm looking for. Well, maybe I should move those faces a little bit if I was being responsible. Let's go do that. So right before the detent fillets, move face, offset, 0.1. Flip direction. detent clearance. That might permit a little bit too much weeble wobble. Let's go 0.05. And we can't have weeble wobble. Absolutely not. No weeble wobble here. .4, so we're still losing the tunnel. Yeah, okay. I think that's good to go. That took me almost an hour. I was expecting it to take me roughly 20 minutes, so whoops. To the one person who showed up 5 minutes ago, sorry that you're just catching the tail end of this. You can always rewatch it at like 2x speed, and you'll get about as much out of it. If you have any questions and you're watching this later down the line and you want to know how I did something, if I did it too fast, or you think I could have explained something better, please, please, please ask me in the comments. I'm always happy to answer. Somebody pinged me just the other day that I'm kind of disappointed I didn't see for 2 weeks, asking for an STL of a part that I designed. So, you know, every little bit that someone finds interesting is what I'm here for. So, yeah, that's everything. Have a nice morning, midday, evening, or night. Boink. Oh, someone just joined. I am so sorry. I'm just about to end the stream. Well, for your sake, I'll run through it quickly again. I had an idea. What if, instead of having constant vertical cross sections, let's just hide this part for a second. Instead of having constant vertical cross sections for my detents, what if they were always radial? So that I would always have a slope that is equivalent across the whole face. So anywhere in this cross section, it'll be mathematically, or as close as SolidWorks can get it to radial relative to the center axis here, which should give me very nice rotation. Okay, that's all I got. Thank you. Boink.